Hi there, welcome to Simplified Discrete Math for Computer Science. So for this session, we shall have an introduction to discrete math and its applications. Discrete math is a branch of mathematics that deals with countable, distinct and separate objects rather than continuous quantities. It is concerned with the study of structures and algorithms used to represent and manipulate discrete objects. Therefore, discrete math is a theoretical foundation that equips computer science students with essential mathematical and logical tools for problem solving and designing algorithms. So this tutorial will help you to build the skills necessary to excel in this field. Alright, so let's dive into the applications of discrete math. Discrete mathematics is used to design and analyze data structures and to study the complexity of algorithms that manipulate data structures. For a beginner, data structures will sound new to you, but that shouldn't worry you because we shall be covering data structures in the future. But as of now, data structures are more like collections for organizing, processing, retrieving and storing of data. Later on in the course, we shall discuss set theory, and you will realize that the set theory is used to understand how data elements are organized and related within a data structure. So for example, the unions and intersections are fundamental concepts when working with data structures like arrays, lists, and sets. Discrete math is also used to study computer networks and security. When we talk about a computer network, it is an interconnection of computers for resource and information sharing. So discrete math is used to study the properties of networks and to design and analyze algorithms for tasks like routing and congestion control. So for example, Boolean algebra is used in network protocol designs, particularly in the creation of logical conditions and rules for packet switching, for packet forwarding, filtering, and firewall operations. Discrete math also provides a mathematical foundation for the development of secure cryptographic algorithms, the generation of encryption keys, and the analysis of security protocols. It also ensures the confidentiality, integrity, and authenticity of data in modern communication and information security systems. So first and foremost, a cryptographic algorithm is a mathematical equation that is used to scramble plain text to make it unreadable. So with cryptography, we work with data encryption, which works with encoding of data through conversions of data into a form that only the sender and the receiver can understand. So for example, currently we are using the HTTPS, which is the Hypertext Transfer Protocol, secure, for data security. So this protocol works with the SSL certificates, which is the secure socket layers, to ensure that data is encrypted while it is transferred over a network. Boolean algebra is also used in designing and analyzing digital circuits, which are used to build computers and other electronic devices. Digital circuits are built using logic gates, which perform logical operations such as AND, OR, and NOT operations. So we shall see all these logical operations in Boolean algebra. Discrete mathematics is a valuable tool for researchers and professionals in computer science, information technology, and related fields. Researchers use discrete math to create new algorithms, analyze their complexity, and address problems in areas like data analysis and artificial intelligence. I hope this session was informative. Thanks for watching, and see you again in the next Boolean algebra session.